We are understanding inertia first law of motion. Inertia first law of motion. First law of motion is also known as inertia of motion. First law of motion is also known as inertia of motion. We will classify inertia into different. Let's start this lecture from friction, from Newton's first law of motion. Friction is what? Friction is what? There will be two bodies. Okay. There will be two bodies. Try to understand carefully. Friction is what? Again, here I am taking these objects to understand meaning of a friction. These are two objects, isn't it? These are two objects. One object I put on this object. Now, when I will apply force on any object, let's say I am applying force on this object. So here I am pushing this object. I can pull this object. It's my choice. So here I am pushing this object. It means it's a force. Force is just a push or pull. Clear meaning of a force? It is clear. Force is just push or pull. If you pull something, it means you are applying force. If you push something, it means you are applying force. Without applying force, anything cannot move. Anything cannot move. Yes. Now, I am pushing this object like that. So here, rubbing of this object of this surface of this object between, it is a rubbing. Surface of this object is a rubbing with the surface of this object with another object. So rubbing part is a friction. Rubbing part is a friction, and friction will happen when force is applied. Then friction will happen. If a force is not applied, then friction will not happen. Clear? Now, it means opposite forces stops this. As opposite forces stops the object. Now, types of friction. It is said that types of frictions are non-contact friction, contact friction, which means there will be two or more bodies, physical bodies. Then there will be contact of another bodies with the other bodies, with the other object. As you saw here, this was one object, this is another object. Now when I applied, so I applied by my hand, this is known as contact. So this hand came into contact with this object. And one type of friction, which is when there is a non-contact, for example gravitational, magnetic effect. If you have two magnets like that, when you will put two magnets like that, then if this is S and this is N, then this will attract this, so this is known as magnetic effect. Now here it is not doing anything, but this has what? Magnetic effect, and this will attach with this object. So here, without applying contact force, it is happening, and this is known as non-contact friction. This will come like that. Magnetic effect, electromagnetics, gravitational, these are non-contact friction. These are non-contact friction. Okay. Now we are talking about, we are going to talk about law of motion. You can say it will be a property of a motion. We cannot change it at all. Law is, it is a rule of a motion. Okay. Let's start from first. Newton's first law of motion. If an object is in rest, then that body will be in rest. That body was in rest, but impact of that body will be when external force will be applied on that body, then there will be impact. That body will come into motion. That body was in rest, that body will be in rest, but when external force will come, when external force will be applied on surface of that object, then that object which was in rest will come into motion. That is what first law of motion. It will happen. It is a property. We cannot change. It's a nature, you can say. It's a nature, you can say. And you observe in your daily life. You observe. You can see. This was in rest. Yesterday this was in rest. Today it is in rest. This body is in rest. After 2 days, it will be in rest. Anyone can move this on anywhere. Anybody can move this, can shift this to over here. So it will happen when somebody will apply force on this there. So this process that I am telling you, it is a first law of motion, which is a law of motion. It will happen. It is happening. It will be happening. It was happening 50 years ago, 60 years ago. Even we cannot imagine. It is happening right now. Right now it is happening. This first law of motion, it is happening right now. 50 or 1000 years later, it will happen. It will be happening. So okay, did you understand first law of motion? It explains that any object is in rest, will be in rest, but when external force will be applied on that object, then that object which was in rest will come into motion. That's it. Second statement, second sentence, you can say, if there are two objects that are in rest and one is in motion, when a object is in motion and a object is in motion, it will be in motion. Okay? It will be in motion, but when external force will be applied on that object which is in motion, then it can accelerate. That motion can be stopped. That moving object can be stopped by applying external force. By applying external force, that object can accelerate. By applying external force on moving object, this moving object can be accelerated. So here, impact you are observing. If an object is in motion, it will be in motion, but when external force will be applied on this moving object, then this object will stop. This object can be stopped by applying external force. So this is one impact. Another impact, this moving object is in motion. Somebody applied force like that. Now it will accelerate. it will increase. A speed of this object will increase, because somebody applied like that force. So a speed of this will increase. It is known as acceleration. Now here this is impact. A speed of this object increased because of external force, because of applied external force. So this is impact. Clear? This came into more motion, and first this came into rest. So by applying force, we can change the shape of object. By applying force, we can change the direction of moving object. By applying force, we can increase the speed of moving object. By applying force, we can decrease the speed of moving object. By applying force, we can do what? If object is in rest, we can apply acceleration on that object which is in rest. So we are clear about Newton's first law of motion. Remember, it is also known as inertia of motion. Clear? Inertia of motion. Now from here you have to understand inertia of motion inertia of rest, inertia of direction. This three is inertia of rest. If a object is in rest, then if a object is in rest, it will be in rest. When external force will be applied on that object which is in a rest, then there will be impact. It will come into rest. It will come into motion. So that object which was in rest, it will come into motion when external force will be applied. So so that happened because of inertia of rest. Now inertia of motion, it means a object is in motion, a object is moving. Now when external force will be applied and there will be impact, so it will happen due to inertia of motion. Now inertia of direction, it is saying direction of an object will be same when it will turn into different direction. Then it means somebody applied external force. So it will be in same direction. Motion of an object will be in same direction, in one direction, you can say in one direction. When external force will come to the surface of the object which is in motion, then it will turn into another direction. So this happened because of inertia of direction. Clear? We are crystal clear about inertia of motion, inertia of rest, inertia of direction. Now my question is, this is my question. This is question from my side. From this question, you will observe, you will understand something special that we understood, that we have understood. Now, question is asking, why is it advised? Why is it advised always to wear seat belt when we are in car, when we are in vehicle? Then why is it advised to us? Reason is what? Reason is, these are reasons. These are reasons. When we are in vehicle, when we are in vehicle, and here vehicle is in motion, vehicle is moving. Vehicle can turn into another direction, into any direction. Vehicle will be in motion. It can be in rest. It can be in motion. Yes. So from this example, from this equation, we can understand this, and about this. Hold on. Here, outside of your home is what? Is standing a vehicle. You are ready to go your school. To go your school. Bus vehicle is waiting for you, and you go and sit in the bus. You take a seat. Okay, you take seat in the bus. Now, vehicle was vehicle was in rest. Vehicle was in rest. So we can say that this was in rest, and now vehicle will start driving. Will start driving by a driver. It will happen by a driver. So now it will come into motion. It happened due to inertia of rest. Now it came into, so where is a external force? So external force is what? Engine of the vehicle. Engine of the vehicle is external force. Okay. Engine of the vehicle is external force. External force. Now it came into motion. It was in rest. When external force, which is engine, external force was applied, then it came into motion. So this happened because of, due to motion, due to rest. Now vehicle is in motion. Now vehicle is in motion, in which you are sitting. Vehicle is in motion. Now, if a vehicle is moving with the same speed, after interval time, then we can say vehicle is moving. Motion of a vehicle is a uniform motion. If a speed of that vehicle is increasing or decreasing, then we can say motion of that vehicle is non-uniform motion. Clear? Now vehicle is in motion. Vehicle is in motion. It will be in motion. Yes, until external force will be applied. Until external force will be applied. Now driver brakes. Driver apply brake to take other student, to take a student. So now this vehicle was in motion. Now driver applied brake to take what a student which was outside of the vehicle, who was outside of the vehicle. So this vehicle was in motion. Now it came into rest because of because of due to motion, because of inertia of motion, because of inertia of motion. Here, what did driver do? What did driver do? So answer would be driver applied external force by device, you can say. So external force is what? Engine of that vehicle. So engine of that vehicle is the external force. Vehicle was in motion, it came into rest because of external force, and the external force of the vehicle is engine. Clear? Now direction, in the sharp direction. It start driving. Okay, it starts driving. Now it takes a turn like that. It was going like that, and it takes a turn like that. So of course here he applied what? He applied this. You can say, I don't know what is this. So this is external force. This is what? This is external force, and that's why this vehicle turned into this direction. So any vehicle is turning into another direction, then because of external force, and external force this is okay. So it happened. Reason is this inertia of direction, inertia of direction. Clear? So it is advised to wear a seat belt when we are in any vehicle, so that we are in rest. When we are in a vehicle, then we are in a rest. Then we are in a rest, and anytime driver can apply brake according to requirement, according to need. It will happen. Yes. Now our body will be in a rest. And when a driver of the vehicle will apply brake, then this upward part of our body will come into motion like that, into motion. And if we are not if we didn't wear seat belt, then this whole body will come like that. So here our body can damage, some parts can damage. So for our safety, because when if a vehicle is in motion, then according to need, vehicle will take a brake, then our body was in rest, then immediately our body will move like that. So of course some parts of our body will damage. To prevent this, we wear what? Seat belt when we are in vehicle. There. And other thing happens what? When vehicle is in rest, then when it will start, when driver will start driving, then immediately we will come like that, isn't it? So here our body backs like that, our body takes like that motion. So to our safety, for our safety, we use seat belt in while driving. Now next, Next, we have understood this. Next is this is question. Mass of this is this much, and mass of this ball is this much. This is surface, which is the contact. Now question is asking, do all bodies have the same inertia? I would say no. No, no, no. If this is in rest, then it will take more force. If no, no, yes, if mass of this is more mass, so of course this will take more force to come this into motion. If this is in motion, then of course it will take more force to stop this. If this is in rest, mass of this is less mass, okay, so we will apply less force, less force, and if this ball is in motion, then we if this is in motion, then we can apply less force to stop this. If mass of the product is more, then we will apply more force. So answer would be no. It depends on mass of the product. So you can say the inertia so here what is mass? So of course it will depend on mass. What is the mass of the product? If mass will be more, then force will be applied more. If mass will be less, then force will be applied less. Now next is what? Second law of motion. We will understand second law of motion with momentum. Remember, law is a rule, law is a property of motion. We cannot change, nobody can change, it is a nature. It is a nature. We are understanding law of motion. With this understanding of this, we will understand momentum. Now, momentum. Meaning of momentum is what? This is the meaning of momentum. Now let's understand meaning of this. Produced, the impact produced by the object depend on their mass and velocity. It is saying, uh, this is wickets. Okay, this is wickets. This is wicket. Clear? So here, from momentum of a object will give you impact. Will give you impact. So there will be more impact or less impact. It will depend on mass. Yes, it will depend on their mass and velocity. If a velocity is fast, velocity of that product is fast, so of course impact will be more. Impact will be more. And if mass is more and velocity is also more, then of course impact will be more. If mass is less, velocity is less, then little teeny impact, there will be teeny impact. If mass is more, velocity is less, little impact. If both are more, then impact will be more. So from momentum, you observe what? Impact. So there will be impact when mass and velocity of a object will be more, then there will be more impact. Hold on. If mass is normal, okay, mass is normal, not high, not low, and velocity is very high, very high. Then of course there will be impact with it. I cannot say less impact, not more, but yes, middle normal will be impact. Yes. So remember, momentum will tell you impact and to now impact of an object, then just increase the velocity and mass. The mass. Now let's understand this with an example. With an example, there is a ball. There is a ball, and this is a box. Okay, there is a ball, and this is a box. Now what will happen? When external force will be applied on this and also on this, then what will happen? What will happen? And with the same speed, with the same speed. So here, uh, mass of this is what? High. Mass of this object is more as compared to mass of this object. Now force is applied on this object. Of course, velocity will be same, and in this case, velocity will be same. Now friction of this will be more, and friction of this, I think, friction of this will be more. Friction, if a speed is the same thing, a speed is the same thing. So friction of this will be more of this, and friction of this will be less if a speed is the same. Okay. To more friction in this, then we have to apply more force. To find momentum is also represented by P. Just multiple mass multiple velocity. Mass is represented by M, multiple velocity. Velocity is represented by V. So to find the momentum, just multiple mass by velocity, then you will get momentum. Now let's understand Newton's second law of motion. We understood meaning of momentum. It tells you impact. Mathematically, when you will multiple mass with velocity, then you will get impact of an object. This is meaning of the second law of motion. We will understand this for the smaller ball. This is complete. From this you will understand. From this you will understand something special. Here, from this you will understand F is equal to mass multiple what? Mass multiple acceleration. Velocity is just acceleration, you can say. Now Newton's second law of motion, it explains the rate of momentum. The rate of momentum of a body. Impact of a body is directly proportional to the applied unbalanced force. If unbalanced force, which is the external force, it is applied, then momentum of a body will increase. If momentum of a body is increasing, then unbalanced force will increase. If momentum of a body will decrease, then unbalanced force will increase. So it will happen when this is meaning of a directly proportional. Okay. In the direction of a force. In the direction of a force. In the direction of a force. You can understand here. You can understand here. If a force is applied, then if a force is applied more, then time will take, then it will take more. Force is being applied more, then of course it will take more time. So this force which is being taken is with respect to time. If this will take more time, so of course this is taking a force like that. So with the time it is happening. The rate of momentum of the body is directly proportional to the applied and foreign forces in the direction of a force. Now here this is a ball, which mass is more than this. Now here a force is being applied. A force is being applied on this object. It started running. It started running. It will come to this. It hits on surface of this object, and now it comes in motion. Now, how much it will take? How much will it take time to stop itself? So that time and that force, you can say initial velocity and financial velocity. So this motion which is taking time, of course, when this ball will hit on the surface of this object, then initial velocity will be high, but final velocity of this ball will be low. That's why we are taking motion as a velocity, not as a speed. So here we are observing what acceleration. Meaning of acceleration is what? Increasing a speed, decreasing a speed. It is the meaning of a acceleration. So at the initial position, it will take more speed. At the final position, it will take lower speed. This is meaning of acceleration. And now you can observe mass of this object. If mass of this object will be less, then of course motion of this object will be more. If mass of this object will be more, then of course motion of this object will be less, and it will take less time. That's why we find what? F is equal to m multiple a. F is equal to m multiple a. M is the mass and a is the acceleration. When force is applied by an object, when a force is applied on object and it hits on the another object, then that object which is being hit, that object will take motion, and motion will take time. So here if directly proportional to, so here there is an impact, is known as a momentum. So delta P upon T. T is 4 because it will take time. Motion takes a time. Rest does not take a time. Motion takes a time. If directly proportional to this, when this will increase, so of course this time will increase. When this will decrease, then this will decrease. Clear? This is depend on this. This is a depend on this, isn't it? Meaning of this is what? It will increase, then time will increase. When it will not increase, then time will not increase. It will decrease, then time will decrease. Clear? Otherwise you can say it will depend on this. When this will move, then time will move. Now to remove this proportional, you can use this k to remove this. F is equal to k. K is a constant. Value of k is said that it is a value of k is a 1. Okay. Now what about delta P? It is nothing but mu, I think mb minus mu upon T. In this, M is common and V minus U upon T. V minus U upon T is a formula of acceleration. Is a formula of acceleration. To find acceleration, just take final velocity and subtract initial velocity from final velocity and divide by T. You will get acceleration. You will get acceleration. So can we say, and value of a k will be 1. So that's why here V minus U. So I have written here. That's why F came as a M into A. Finally, you can say F is equal to MA. Meaning of this is what? Force will be more. Force will be applied more. Force will be applied more on an object. When force will be applied more, when force will be applied on an object, then that object will hit on another object. Then that object will come into motion. Otherwise, that object will take acceleration, will accelerate. So there is impact. Of course, this is impact. Now, motion. We will take motion of that object which is started moving, which accelerated, and how much it took time. How much it took time. We will take this. You can see. The initial velocity of this mass. Final velocity of this mass minus initial velocity of this mass upon T. How much time it took? Then from this we will get force. How much force was applied on this object? And now you can find what A. Then you will get F upon M. You can find from this. You can find M. Then you will get F upon A. Clear? Now next. Next is what? This is the meaning of Newton's third law of motion. It explains if external force is applied on object, then it will provide what reaction. that object will provide a reaction. When I will push something, then that object will take what motion. So as I took action on that object, as I applied action on that object, so same reaction of that object will be there, will be there. So it happens in nature. Okay, it is a nature. It was third law of motion. It is a property. It is a property. You can observe force in your daily life. You can observe reaction, friction in your daily life. You can observe what mm, forces. As I told you, force can change something, shape of object, increase of object, speed of object. Yes, it can be done by applying force. So this explains, if external force is applied, then that we applied this is one, and now that object will provide a reaction. That object will provide reaction. Okay. Now tell me what is the formula of a speed? What is the formula of a speed? Do you know what is the formula of a speed? You would say distance upon time, because a speed takes time. Because a speed takes a time. Now, how much distance was covered by vehicle will be distance. Okay. Now there is no direction. That's why a speed is a scalar quantity. It is a scalar quantity. So unit of this would be what? Meter per second. Meter per second. A speed on the vehicle. A speed. As a speedometer tells you, which is found on. It tells you what a speed. A speedometer tells you a speed of that vehicle, and it is found in vehicle. It is found in vehicle. Of course, you know. Now this a speedometer will tell you a speed in meter per second. Okay, in meter per second. With how much speed? With how much speed your vehicle is moving? Who will tell you a speed? Odometer will tell you how much distance was covered from this, from that. So odometer device will tell you, and odometer will tell you distance in distance that was covered will tell you in kilometer per hour. Clear? Now this is a formula for distance upon time. Distance upon time. What about velocity? Displacement. Displacement. What about displacement? As we know, displacement. To find displacement, I think total distance. It is a yes. Total distance. Total distance upon time. Time taken. So unit of this would be same. But what's the difference between them? It is a shortest. It is a shortest distance. This is a total distance. It is a shortest distance. It will tell you the speed. Okay. Now what else? Velocity. I think velocity. Average speed. Average speed. To find average speed, you know what will you do? Just take initial speed and final speed. So final speed minus initial speed upon t. This will give you average speed. This will give you average speed. It will be in meter per second. Now velocity. Velocity. Uh, of course, not u minus v. Displacement. I think displacement upon what? Displacement upon time. But remember, what's the difference between speed and velocity? It will take a distance displacement, but it will not take any direction. Clear? Average velocity. Average velocity. Yes, it will tell you in meter per second. Okay. To find average velocity, it is saying that it will take a vehicle will increase the speeds according to requirement. Vehicle will increase the speed. So that's why we take initial speed, final. I think this would be plus u plus v. Initial speed add with final speed by divided by time. Then you will get average velocity. You will get average velocity. What's the difference this and this? It will take turns. It can take a lot of turns, but it will not take. It will not take average speed will not take uh, a speed. Clear? Velocity is a displacement is a vector quantity. A velocity is a vector quantity. What about acceleration? What about acceleration? I think it would be u minus v upon t. This is the acceleration. U is a final velocity, and v is initial velocity upon time. So how to find acceleration? Just find the final speed and find the initial speed. Subtract initial speed from final speed and then divide by time. You will get acceleration. You will get acceleration. Did you understand? Now I have a question. You have to tell something. Based on motion. This is computation. You got this. You have given four options. You have given four options. Now here the motion of the pendulum bomb. This is what watch. 1, 2, 3, 4, like that. Okay. 6, 7, 8, 9, 10, 11, 12. This is here. This is way like that. Now pendulum is here like that. Clear? It is moving like that. Okay, it is moving like that. You have to tell the motion of the pendulum bomb. This motion of this, not motion of this hand. Motion of this is what? How? Circular? No, no. It is not circular. Okay. And periodic? First of all, this is not answer because of this. Rectilinear? No, 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 no. It is not moving like that in direct in straight direction. Oscillating and non-periodic. Non-periodic. Oscillating and periodic. Here, of course, it will take time. This, if this moves here and then again it will move like that. So interval time it takes. Yeah. So we would say oscillating motion. This would be answer. Let's explain this oscillating. Oscillating, which means through and fro. Through and fro like that. This is meaning of oscillating. Okay, oscillating. Periodic, which means interval time. If it start from here, then it will go and then it will go like that. It will come here. So this is periodic time. And oscillating, which means through and fro. Through and fro. Like that motion is oscillating.